chemical property that we're going to talk about is the idea of transition metals as catalysts. So hopefully from your IGCSE year, you remember that catalysts speed up a chemical reaction. Okay? They speed up a chemical reaction by providing an alternative pathway for the reaction to happen. Now, specifically, let's talk about transition metals. So transition metals can easily form different ions, right? We talked about that in terms of variable oxidation states. So for example, you might have iron 2 plus that can very easily turn into iron 3 plus and vice versa. Iron 3 plus can very easily turn into iron 2 plus. What that means, therefore, is that transition metals can gain or lose electrons relatively easily. Oops. So the idea that they can gain or lose electrons relatively easy is awesome, because what transition metals can therefore do is they can provide an alternative pathway for electron transfer. So if my reaction that I'm trying to speed up involves the transfer of electrons, and most reactions do, then having a transition metal as a catalyst can provide an alternative pathway for those electrons to be transferred. Okay? Some examples of transition metal catalysts might be platinum and nickel. Those are both used in cars as catalytic converters, where they help the reaction of turning toxic gases like carbon monoxide and nitrogen monoxide into less harmful gases. Another example is iron. Now you'll notice that I put these under heterogeneous catalysts. That's when the state of our catalyst, so all of these guys are solid, that's when the state of our catalyst is different from the state of the reactants. So for the example in the car, platinum is a solid. The reactants that it's helping form products are both gases. Okay, so that's what we mean by heterogeneous catalysts, and usually transition metals are heterogeneous. Just to look at the opposite side of the coin, when we're talking about homogeneous catalysts, they're catalysts that occur at the same state as our reactants, and that's usually more biological catalysts, aka enzymes. So these guys are usually dissolved in water, so aqueous, and the reactants that they're trying to speed up the reaction for are also usually aqueous. Okay, so transition metals can act as catalysts because they very easily gain or lose electrons, and therefore provide an alternative pathway for electron transfer.